Alright, this is video one of the flipped classroom idea. I know I'm not here today. You're like, Rockhold, what are you doing? I told you about the fact I hit my head the other day and I just not supposed to be here. Other things. So I'm just not completely cognitively aware, so these videos are going to be slow, meticulous, and I'm sorry. I apologize in advance. I know you're like, don't make these boring, bud. They're going to be boring. You know, whatever. It happens. It's life. You know, deal with it. Okay. Plan for the day. And if it hasn't been explained to you and you didn't read the page that was before this, I'm going to teach you something. Then you're going to take a little quiz. Then there's going to be the worksheet, which is I'm actually holding in my hand to prepare you for. Surprise, I'm teaching the worksheet. Amazingness. So anyway, I'll do that. And then after we get done with that, then there'll be another little video, another little quiz, another little worksheet, another little video. Just the second two videos are recap videos. And then after that, you can actually get the final assignment at 9.3. So they're labeled 1, 2, and the homework assignment front. As you do them, get them done, turn them in before you grab the next one. You're expected to turn in all three. If you are on with it, you should be all three done today. If not, the ones you don't get done, bring it back. Okay? Treat them as homework. Because they are. Okay? You will be graded on all three papers. So, the first paper is conditions for parallelograms. So the thing about parallelograms, like, there's a lot of stuff that goes with these things, roughly this shape. So the opposite sides have to be parallel. Parallel means their slope is exactly the same. So if I said this slope was 2, if m equaled 2 here, then m also has to equal 2 here as well. These sides have to be parallel. Believe it or not, it's called parallelogram because parallel sides. These two sides have to be parallel as well. I'm using single arrows on this one to indicate these are parallel, and double arrows to indicate these are parallel. The double arrow is parallel to the double arrow, and the single arrow is parallel to the single arrow. I'm going to say this is m equals 0, and m equals 0. Okay? So, notice my slopes match again. That's very important. So, one condition is both pairs of opposite sides are parallel. I'm going to say it again. Both set of opposite sides are parallel. That's a condition. Now, I'm going to go quickly through a lot of these things. I'm not going to pause for too long. If you need to write stuff down, like, I'm saying the words because writing it down, my hand hurts, my head hurts. It's 9 o'clock at night, so understand this. Like, if both sets of opposite sides are parallel, that's enough to prove that it's a parallelogram. All right? If you need to pause, go back and write that down too. Next condition, that it's a parallelogram. A set of opposite sides is both parallel and congruent. So these two have the same slope, which means they're parallel. This mark indicates they're congruent. So this is like saying m is equal to 3, and this is 7 units long. This is 7 units long, m equals 3. Notice the slope is the same, so they're parallel. The sides are the same length, so they're congruent. Therefore, it's a parallelogram. Next condition. Both sets of opposite sides are congruent. So like if this is AB, CD, then AB is congruent to side DC, and they're opposite, and AD is congruent to BC. Since that's true, this is again a parallelogram. These are all individual conditions. They're enough to prove it themselves. You don't need anything more than that. Just one bit of proof, right? Like, I don't need to say all of these things. It's just, if both pairs of opposite sides are congruent, it's a parallelogram. If one set of sides is opposite or parallel and congruent, one set of opposite sides is parallel and congruent, then it's a parallelogram. Over and over and over again, okay? Next condition, both pairs of opposite angles are congruent. So if these are congruent and these are congruent, it is automatically a parallelogram. Okay, easy enough. If the diagonals bisect each other, this list of stuff is posted. So if this diagonal and this diagonal cross, and these two are the same and these two are the same, meaning they're bisected, therefore this is a parallelogram. And then another modification of the opposite angles are congruent, those pairs of opposite angles. If I gave you this here, and said this is 60 degrees, and this is 120 degrees, and this is 60 degrees, notice, remember a quadrilateral, 4 sides, so we do 4 minus 2, which is 2, times 180, so it's 360 degrees. If we do 360 minus 60, we get 300, minus 60, we get 240, minus 120, we get 120. So this is the same. We could figure it out, but we have a theorem that says if one angle is supplementary with its 2 consecutive angles, so 120 and 60 is 180, complementary, or sorry, 120 and 60 is 180, which is supplementary, and 120 and 60 is 180, which is supplementary. So this single angle is supplementary with both consecutive angles on either side of it, therefore it is a parallelogram. Those are the conditions, all right? So I'm gonna throw up some things. I want you're gonna have to pause, okay? Because I'm just gonna throw them up, give you a moment, then I'm gonna talk. So I'm gonna throw them up, do what you think, answer what you think, because if you don't do it, you just play the video, that's not gonna help you. So answer what you think, and I'll explain why, what it is, and all that. So is it a parallelogram? Is it not? And why? All right. So I'm gonna label these A, B, C, D. Okay? Pause at this moment, answer if you think they're parallelograms or not. Okay, I'm back. All right, so this one is reason why both sets of opposite sides are congruent. Both sets of opposite sides are congruent, therefore it's a parallelogram. B, yes, it is. How is it a parallelogram? One set of opposite sides is parallel and congruent, therefore it is a parallelogram. C, yes, it is. How? The diagonals bisect each other. So these diagonals cut each other exactly in half, because these halves of this diagonal are congruent and the same here. Therefore, yes. And it is not a parallelogram. Why? The opposite angles, both pairs of opposite angles, are not congruent. Notice these two angles are not congruent. Automatically not a parallelogram. I don't even have to check these, which also aren't congruent. But because the first set of opposite angles was not congruent, therefore it's not a parallelogram. Don't need to do anything more. Case proven. All right, you should be able to do side 1 and side 2 of worksheet 1. All right, this back side you have to do a little algebra. Give it a shot, see how you do. Finish it up. Actually, first you gotta do the quiz, then you do the worksheet, and then we'll come back for the second little review, and we'll do some algebra stuff, and you should be fine.